amount of oxidized lipids in blood in general, then this would play a critical role. Because again, it's repairing and returning good lipids back to the LDL and LDL and IG. Okay? All right, so again, we have sort of explained almost everything, the maturation of HDL particles and the two enzyme activities associated with it, an exchange protein and an acylase, and the sort of protective role HDL can confer on the body. And remember, when it goes from a flat tire like this to the mature particle, this is now called HDL2 or 1. Right, so it goes from HDL3 to 2 to 1, which is the sort of the largest diameter, if you want to call it that, or the most mature form of HDL particles. All right, so again, one final aspect is this part, is the possibility or the role of the LDL particle and a product of it to generate an atherosclerotic flow. Again, part of the idea is that it isn't simply cholesterol levels. It's the combination of generating, quote, bad lipids that are recognized by the immune system. So let's say you start to accumulate oxidized sterol in LDL particles in blood. A monocyte, one of the phagocytic white blood cells in our blood, will recognize this and take it up into, let's say, the wall of a blood vessel. Remember, it's taking it out of circulation. Once inside, this becomes now known a macrophage. It just requires a different name. Macrophage, phage as in eat. All right. And now the macrophage will keep swallowing, so to speak, this, eventually dying and forming, as I showed you in the slide, these foam cells. Again, all of this is in the wall of the artery. And a foam cell is simply a bag of oxidized lipid that's being sort of sequestered there so it doesn't collect in the blood. The bad thing about this is it becomes scar tissue. So this becomes thicker and thicker and thicker because not only is it a foam cell, but it also recruits support tissue to protect it, like smooth muscle will come and surround it. All right, so foam cells. And remember, part of this process is also bringing in inflammatory cytokines. All derived, remember, from eicosanoid or arachidonic acid. Because this is an immune response. So it makes sense that the monocyte saying, whoa, there's something bad here, let me take it in, recruit some of these defensive cytokines, all right? So it's a combination of bad metabolism plus an inflammatory response. And you know what? The more diseases you'll see, the more you'll see that this combination is common in almost every disease. All right, but this in particular. All right, so a foam cell is a terminal cell, a terminal bag, if you will, of bad lipids, and add to it an inflammatory response exaggerating this process. And of course, as this accumulates, it's occluding blood flow, and worse, it's making this very solid. A blood vessel, especially an arterial blood vessel, has the capacity to expand and contract with each pulse. This is very stiff. And this is essentially what's going to happen. Eventually, this will break or rupture, as I showed you in that video, which is where typically coronary occlusion happens and thrombosis and so on. Okay? So again, it's a combination of any factor that contributes to the accumulation of LDL cholesterol in blood, and again, I give you all the examples of that, plus factors that could contribute to its oxidation. Lifestyle, exercise, smoking, diet, all of these result in a perturbation in this ratio. And then, of course, the body's own immune response. If it's heightened for some reason, and it's very prone to doing this, you patients who will be early, for example, atherosclerosis. Okay? Yes?
So I just want to understand this better. So when we're talking about oxidation here in the lipoproteins, it's more than just cholesterol ester, right?
No, that's not enough. Remember that slide that summarized the pathways of cholesterol metabolism? One going to the cortical, one going to the cortex, one going to the bile acids. And there was a little box on the upper right. There's the oxidized products that are there. Oxysterols, that's called. And you can look at it, it's just oxidation products of cholesterol that have no function whatsoever. All right? So no, esterification is a necessary, reversible process. Because once this gets into a cell, remember I gave you the example of ACTH stimulating the uptake of cholesterol from LDL particles. Another aspect of ACTH stimulation was liberating this. It stimulates cholesterol esterase by phosphorylating and activating it. So this is just a precursor, but this is a reversible, and it's in a cell, not an HDL. This is a reversible pathway by which you can store cholesterol ester and liberate it as needed. Right? It isn't a pathological buildup. Okay? Any other questions? All right, so again, I'm going to now switch to the lecture and the slides, and we're going to try and explain the major metabolic disorders associated with hyperlipidemia, all right, as opposed to hypolipidemia, which is really benign. Hyperlipidemia, again, what is most pathogenic is hypercholesterolemia. Imbalances in lipoprotein metabolism. I'm going to just preface this by telling you there's a classification here that really is awful. And it has nothing to do with me. It's what's available out in the literature. It classifies them according to, sometimes it doesn't seem very logical. I just want you guys to remember, why would I see accumulated TAG? Why would I see accumulated cholesterol? Their names, their classes, doesn't really matter, all right? Because as you're going to see in a while, some of them really don't make much sense. Okay, so type 1 is type 1 hyperlipoproteinemia is when the TAG accumulates in the blood. And typically it's TAG from the diet. So exogenous hypertriacylglycerolemia, even though you'll still see hypertriglyceridemia, I don't like that term. All right, so this anything that contributes to an accumulation of TAG in the blood is a type 1. And there is a familial form of fat-induced, again, lipemia synthetase lipid in the blood. And if you go to the next slide, hyperchylomicronemia almost gives it away. Because this suggests, again, that first couple of factors I mentioned, that there's something wrong with that initial metabolism of a TAG-rich particle. And since it is exogenous, by definition, that particle is chylomicron. What could cause chylomicrons to accumulate in the blood? Either a deficiency or a mutation in lipoprotein lipase, or something wrong with ApoC2 sequence so that it doesn't activate lipoprotein lipase. Or, as I told you, in a very rare case, you have an overexpression of the inhibitor of lipoprotein lipase, ApoC3. So what you see in these patients, especially after a meal, is very, very high levels of triacylglycerol. In fact, you look at the plasma, it looks almost like milk. It is so, all you have to do is leave the tube in the fridge for overnight, and you can see the excess TAG chylomicrons building. A common manifestation, by the way, of hyperlipidemias is the body's attempt to get rid of them somehow. So funnily, one of the things that the body tries to do is expel those tag-rich particles to the surface of the skin. And this is what you're looking at. They're called eruptive xanthomas. Literally, they drip of lipids that's, in the front of the shin here. A lot of lipoprotein disorders also manifest in the retina. You can even see them. So if you look at the blood vessels in the retina, you can actually see the white or this lipemia retinalis. Again, because you can see the blood vessels in the retina, you can see the lipids accumulate. It's this scary looking white stuff. All right. So again, you would see this. If this is a congenital deficiency, the name implies it, you would see this early in children, especially in response to diets that contain fat. So if you, in theory, if you limited fat intake, you would limit the chylomicron, the substrate of this, and you wouldn't get chylomicronemia. So again, these patients probably have to have very low fat in their diet, and even whatever meals they have should be limited so that they don't generate VLDLs, which could be fat-rich as well.
Wait, that only happens near the shin, or is it like anywhere in the body?
The most common area is in the shin. And you're going to see it again with another type of xanthoma from cholesterol. I actually think you can also see them, I can't remember, I've seen images elsewhere. Type 2 lipoproteinemias, again, a long time ago they referred to the LDL as beta lipoproteins and the HDL as the alpha. You'll still see them, unfortunately. It's much better if you actually spell out what it, and again, in an exam question you would see spelled out. All right. So type 2 is associated with the accumulation of LDL particles. And you should realize that LDL particles can arise in the blood or increase in the blood, either from a direct disorder that I mentioned before, or it's quite common to see from another disease. And one of the most common disorders that can contribute to excess LDL in the blood is diabetes, for example. So that would be secondary to the disease, and LDL accumulation is not, a primary cause. All right, so what are the clinical observations? Again, even in a fasting state, the plasma total cholesterol would be high. The level of TAG may be low or normal, because remember, this is second. This is the step that comes after TAG hydrolysis has happened. But LDL levels will go up tremendously, and of course, total cholesterol is contributed, 65 to 75% of total cholesterol is in the LDL. A quarter or a third is from the HDL. And again, there could be many causes for an increase in LDL concentration threshold. It could be many genes contributed to it, or again, as I mentioned, it could be secondary to some other disease, such as diabetes mellitus. They've classified the primaries, and again, this is a disorder in the LDL metabolic pathway itself, into several types. All right? One class, type A, is a result of defective LDL receptor, and there are many parts of this. Remember, I mentioned there's several contributions. B is due to a defective cholesterol ester transfer protein. And finally, you can imagine that there would be something wrong with the ApoB100 sequence so that it doesn't bind to the LDL receptor. All of which would contribute to an excess LDL accumulation in the blood. So here's another xanthoma, except it's in the heel. So here is type 2A, familial hypercholesterolemia. It is actually very common, especially in the heterozygous form. And again, because of the causes of this attributable to mutations or defects in the LDL receptor, apparently it's quite common. So what you see again, you see cholesterol that can range. Remember, anything greater than 200 is considered pathogenic. They can really soar up to 500 or so. Here are xanthomas, again, where cholesterol, in this case, rich particles accumulate, and this just happens to be in the heel. And of course, these patients will have a very early onset of atherosclerosis, and typically will die very early from coronary artery disease. Again, this is a simple diagram to show you that the VLs and its progeny, LDL and IDL, have ApoB100, which should bind to the LDL receptor. But because of some sort of defect in the LDL receptor itself, either decreased number, mutated sequence, can result in excess LDL accumulation. And this, remember, these are the tissues that are going to clear this LDL particle. So many of these patients will have disorders associated with decreased cholesterol uptake here. So patients, and these are probably children, will have, for example, immature reproductive development because their gonads can't get enough cholesterol to synthesize testosterone and estrogen. The adrenal gland can't get enough to make cortisol, aldosterone, and so on. So it makes sense that the manifestations would reflect decreased cholesterol uptake by these tissues. Okay? This is a second class of hyperlipoproteinemia type B, and it's called familial combined hyperlipidemia. And again, this is where I'm telling you these classes sometimes it's not easy to remember them. And that's why I wanted you just to remember what could accumulate when what is defective. This, by the way, as I told you, is the major form of hyperlipidemia. So again, very common. And the primary defect is attributable to this cholesterol ester transfer protein, which is either reduced in number or in catalysis. Right? So what happens is it simply cannot perform its transfer process of, let's say, good cholesterol ester for bad ag. So what you end up with is you end up with accumulating higher levels of LDL, with presumably oxidized LDL, which contribute to this hypercholesterolemia. Okay? And the third, and please remember that when I talk about the LDL receptor defects, there's a whole family of them. It's not just the LDL receptor itself. It could be the number, it could be the quality. I think there's another class where ApoE is involved. But this is the third class in which it isn't the LDL receptor per se, but what binds to it. And that is the ApoB100 portion, the C-terminal of ApoB100. Mutations in it